Hello, geometry students. Mr. Zacek here, back and better than ever. In Unit 3, going on to Lesson 3, we've got a little more here with parallel lines, and we're going to prove a theorem here. This is going to be Theorem 3-10 in your textbook, but we're going to prove it here today in this way. So it says in a plane, C is perpendicular to B, and we see the right angle that's drawn up here for that. B is perpendicular to D, and D is perpendicular to A. And we need to prove that C is perpendicular to A. So we need to prove that this line here, that if we extend this line out here, that this would also be perpendicular there at that point. So let's see how we can kind of go about doing this. So first thing we're going to do is start off with our givens, obviously, and that's that line C is perpendicular to line B. B is perpendicular to D, and D is perpendicular to A. And all of that is given to us. Now I'm going to number these angles 1, 2, and 3 because we don't have any vertex points there, so we're just going to number them. And now what do we know about perpendicular lines? Well, we know that they form right angles. So we could say angle 1, angle 2, and angle 3 are right angles. And the reason is, if two lines are perpendicular, then they form right angles. If two lines are perpendicular, then they form right angles. If two lines are perpendicular, then they form right angles. Okay, so now what I can say is that angle 2 is going to be congruent to angle 3. Okay, so angle 2 is congruent to angle 3, and the reason for that is all right angles are congruent. Now, what we should see is D is essentially a transversal here, cutting across two lines, and what we've just proven in that scenario is that corresponding angles are congruent, and so we can say that A is going to be parallel to B. So step 4, we could say A is parallel to B. Okay. If two lines are cut by a transversal such that corresponding angles are congruent, then they are parallel. Okay, then they are parallel. Now, I'm going to add an angle here, angle 4, all right? And now I know that angle 1 has to be congruent to angle 4. So in step 5, I can say here that angle 1 is congruent to angle 4. Well, why? Because parallel lines, if two lines are parallel and cut by a transversal, then corresponding angles are congruent. So, and cut by a transversal, then the corresponding angles are congruent. Okay, now what can we say about angle 4? If angle 1 is a right angle, angle 4 must be a right angle. So 6 is going to be that angle 4 is a right angle. That's really just because all right angles are congruent. Okay, now, what happens with lines that form right angles? They're perpendicular. So since angle 4 is a right angle, that means that C is perpendicular to A. Okay, so step 7, C is perpendicular to A. If two lines form a right angle, then they are perpendicular. So we just kind of flip that. If two lines form a right angle, then they are perpendicular. We just flip that around like we did up here in reason 2. If two lines are perpendicular, then they form right angles. We just flip the part after the then and the part after the if. That's called the hypothesis and conclusion. Okay? So that is the proof of a theorem 3-10. It's on page 166 in your textbook. It says, in a plane, if a line is perpendicular to one of two parallel lines, then it is also perpendicular to the other. Okay? So just using the same stuff that we've done. All right, let's do a little more practice here with solving for things and identifying angle pairs. Okay, so what do we know that allowed you to solve this problem? Well, the first thing that I would do here is 8y minus 22 equals 148. Okay, those are vertical angles, and of course they're congruent. So now we can solve that. We're going to add 22 to the other side. That's going to give us 22 and 48, 50, 170. Okay, and we're going to divide 170 by 8 to get what the other side of that is. And I'm trying to do that in my head, but I don't think 170 divided by 8 is 21.25. Okay, now from here we can go 2x plus 20 plus 148 equals 180. How can we set that up? Well, those are same side interior angles, which are supplementary. Okay, so those two have to add up to 180 degrees. So we've got 2x plus 168 equals 180. Subtract 168 from 180, and we get 12. Divide by 2, and you get 6. Okay. So just, reviewing some more things, getting familiar with angle pairs. All right, here in this one, this angle and this angle, those two are equal to each other. So 5x plus 15 equals 4x plus 20. Why? Those are corresponding angles. And we know that corresponding angles are congruent to each other. So subtract 4x, subtract 15, okay, x equals 5. And then we can think about the other one a few different ways. Y plus 5x plus 15 equals 180. Okay, that's a linear pair. And a linear pair is supplementary. We know what x is. X is 5. So 15 equals 180. 25 and 15 is 40. So that would be y plus 40 equals 180. So y equals 140. All right, so just getting some more practice with those and thinking about the relationships that exist here. And one of the things that I want to keep reminding you of is if you have two parallel lines and one transversal, then you're just going to have two different angle measurements. They're either going to be equal to each other or they're going to add up to 180. So let's go ahead. I think you guys could do number 3. I want to do number 4. It's a little more complex because now we add in some extra lines here, and sometimes we have to subtract here. So what I want you to think about in this one is don't get blinded by this line right here. It's almost like if we just deleted that line, we would see there the other transversal, the 2x plus 24 equals 4x minus 10. What we want to recognize is those are alternate interior angles, and those are congruent when the lines are parallel. So I would probably subtract 2x, add 10 to this, okay, and so I'd get 34 equals 2x, and so 17 equals x. All right, and then y is going to equal 4x minus 10 because those are vertical angles which are congruent. Okay, well, we know what x is. That's 17 here. So we have 4 times 17. 4 times 17 is 68. 68 minus 10, y would be 58. So when we start getting into having multiple transversals that go through the same vertex, now we have to kind of think slightly differently. That's a weird verbiage or language. We have to think a little differently and recognize that now we're going to get other angle measures that are a part of that. Okay, so here's an example of how we can use some of these angles in our thought process here. A carpenter plans to install molding on the sides and top of a doorway. The carpenter cuts the ends of the top piece and one end of each side pieces at 45-degree angles as shown. Will the side pieces of the molding be parallel to each other? So as we look at this, what we want to think here is when you bring these two together, what's going to happen? If you can picture this, these two will form together, and those two and these two will create two 90-degree angles. And really what we're doing here is, here's our parallel lines. Will they be parallel? Well, if those two angles are both 90, that means they add up to 180, and therefore we have same side interior angles that are supplementary. So the answer to this question is yes, because the same side interior angles will be supplementary. And so therefore, therefore these little 3 dots mean therefore the sides will be parallel. If you've ever done any molding, it's a tricky thing, the way you have to cut that when you're doing molding, and the types, getting those angles right can be a really tricky thing. Okay, so now one more question. Can you assemble the pieces at the right to form a picture frame with opposite sides parallel? Explain. Okay, well, here's how, again, how we want to do this is, if we take this 60 degrees and we turn one of these 30 degrees up like this, 30 degrees, and we turn one of these 30 degrees here and 60, these shapes are trapezoids, so we got 60, 60, 30, 30. Now we've essentially made a rectangle because we've got all right angles, and so the answer to this question is yes. We could say C diagram, that creates, same side interior angles that are supplementary. Same side interior angles that are supplementary. So not a whole lot new in this, just some different ways of thinking about things, a little bit of some other complexity in it and a couple kind of application type things here at the end, and that's our next lesson. But we're finished up there, so good luck with your assignments and quizzes, and again, just a reminder to always ask and keep on asking.